Hi everyone, this is Festive Tech Calendar 2024. Today we are going to talk about AKS Cluster Mesh in Azure Virtual WAN. This is the 4th of December, which is also my daughter's birthday. So happy birthday to my daughter. And now we can get started with the technical stuff. Okay, so as I mentioned, we are going to discuss about cluster mesh for Azure Kubernetes services in Azure, because, well, we are talking about Azure, obviously. And we will put that into a virtual one. So the agenda will be the following. We'll introduce the cluster mesh concept, and for that we will rely heavily on the Cilium in a bring your own CNI approach, because for now it's not possible to do another way. Then we will have a look at how we can transpose that into an Azure environment, and I mentioned already that it would be Virtual WAN. We'll discuss a bit about why, and then we'll play a bit with the cluster mesh feature and discuss about what we want to achieve, what we can do, what we still need to plan when we consider deploying a cluster mesh solution. With that said, let's get started. So first, the concept. So cluster mesh, as the name implies, the concept is to connect the clusters together so that we can have a cross-cluster availability for the services that are hosted on the cluster. We can also have service that are either highly available across multiple clusters or shared across multiple clusters. We can also consider organizing the different services across the cluster, for example, public cluster versus private cluster and stuff like that. And we can also leverage some nice feature which are in the security area, such as network policies, which we will consider at the cluster level, but with a global view on the cluster mesh, because each cluster will have the capability to accept or deny the traffic from other clusters, so we get a cluster mesh-wide network policy organization. So those are the concept of what we can, well, not the concept, but the feature that what we can get with a cluster mesh. It's important to note that the cluster mesh will have also some prerequisites that we will have a look a little in the coming slide. But first, a little bit of architecture. So I was talking about the prerequisite area anyway. So obviously, if we consider a cluster mesh, that means that the clusters are connected, so we should have connectivity between the cluster. That's why we need to find an underlying network topology that works for that, and that is as simple as possible to configure and to maintain, so that we don't have ideally two levels of management when we consider the networking for our workloads hosted in Kubernetes. There's also some other another important requirement. This requirement is regarding the pod IP ranges. So let's slow down here just a few seconds. When we consider pod in Kubernetes, and specifically in Azure Kubernetes service, you probably know that we have more than one choice, which is related to the CNI. In our case, well, we said that we will work with Cilium, so that's not really what we want to consider here. But just remember one thing: either you have, if you take the AKS picture, either you have an isolated pod IP range, meaning that the pod IP range is not visible directly outside of the pod IP range, and the node, the node share use the network which is not the same as the network of the pod. That's the overlay model. In AKS, you probably know that at first we had to use Kubernetes, which was not ideal in terms of performance, or we used Azure CNI, which was ideal in terms of performance, but used to, emphasis on the used to, share the pod IP range with the node IP range, meaning that everything was in the VNet IP range, resulting in the high consumption of IPs. So that's not the case anymore, as you probably know, but suffice to say here that we are using Cilium with a bring your own CNI configuration. That means also that we use Cilium default configuration, which is an isolation between the pod and the nodes in terms of the network. Because of that, usually when you have one cluster living somewhere, you don't really care about the pod IP range. You can use whatever you want because everything will be routed from the cluster to the pod, and except for some rare exception, usually you should not have issue accessing other services outside of the cluster from your pod. Okay, but that changed when we are doing cluster mesh, right? Because we are connecting the cluster together. So in this case, we also need to avoid overlap between the pod IP range. That means that for the cluster that is the first cluster, and then the second cluster, we cannot have the same IP range between our cluster for the pods. Okay, so another IP range to take into consideration when you are planning for the deployment. Okay, a little bit on the architecture now. In terms of concept, this is quite simple, actually. You have one cluster which, once the cluster mesh is enabled, it will expose a service on the outside, that is accessible from the other cluster, and this service will proxy etcd. And because etcd is proxified, the other cluster will be able to read the etcd that is proxified and replicate it into the local cluster, the other local cluster, and so you will have replication of the state from all the mesh cluster, cluster mesh wide, which is how it's done. So it's work with some kind of proxy and some kind of secret and config map which are replicating all the time. We'll have a look at that when we manipulate a bit on the cluster. The interesting part here is that this is read-only. I'm meaning each etcd proxy is only accessible in a read-only method. There is no read-write from one cluster to the other. So one cluster will read the state of his neighbor, and that's all. And it will replicate that in its own base, identifying as something as it should be. But there is no replication in this sense, so no failure replication. So that means that we don't have a more important blast radius because of the cluster mesh, which is very important from my point of view. Okay, so that's it for the architecture. Just a few words, and that's it finally for cluster mesh concept introduction. Okay, so now, if we want to have cluster mesh in Azure, so that means that we want to have cluster mesh with AKS. And as I mentioned, at this point, the only way to do that in terms of Kubernetes configuration is to use bring your own CNI and then deploy your Cilium CNI on your clusters. Okay, but from the higher level, from the higher point of view, we want to consider how we can have a network that will be able to scale, because we want to have more than one cluster, so we should not share the same network. So how can we do that? Well, we can do let's say the standard from Microsoft, which is the hub and spoke, right? In hub and spoke, each spoke contains its application workload, or I should say each application workloads are hosted in their own spoke, so that we can have micro-segmentation, zero trust, stuff like that. And then if we need to communicate outside somewhere else, we can rely on the hub and spoke, which will allow us to route the traffic from spoke to spoke through the hub, right? So that's typically the model that we want to achieve. But in this case, I mentioned in the introduction that we want to avoid too much complexity into the operating model. And well, let's say that Virtual WAN offers some interesting advantages. Among other things, to the classic virtual network hub and spoke. If we use a virtual WAN with virtual hub, we get under the hood, hidden but still there, an Azure root server which allows us to centralize the routing configuration from the hub, as a matter of fact, and so we don't need to manage how should I say that, user-defined routes between the cluster to manage the routing and all the complexity that you may have come across in your life as an Azure admin. So using an Azure Virtual WAN will allow us to get a simple to manage topology once you have established that each cluster has its own spoke, which is connected to the virtual hub, and the virtual hub is managing the routing. Because it's managing the routing, when we will mesh our cluster, everything should work fine. Okay, so let's just have a look at what we have for now. So we do have in this environment a virtual one, right, with a bunch of network, but we will focus on the network that we are interested in. So where is it already? Virtual WAN configuration. That's not in configuration, it's in connectivity. There, okay, right. And here we can find one hub, which at this point is a simple hub, not a secure hub with a firewall, but we will discuss about that at the end of the session, right? In this virtual hub, we have, in terms of connectivity, not that much. In terms of routing, we kept the default route, so I could write here, I could click here and find that we have only one route. If I want to use an Azure firewall or another security appliance inside the hub, I can manage that with a different route table or using some routing intent and routing policy, but that's another topic, right? So it usually takes time to okay. So you can see here that I do have another route that I don't use because nothing is associated with it. And if I click on this one, you can see that I have 11 connections, which probably represent my different network connection. If I go back to the virtual hub, I should be able to see somewhere my topology. View topology, perfect. Is it readable? Let's wait for that. Okay, it's a little bit small, but you can see that I have a bunch of networks. So VNet Cloud Shell, not this one. VNet Mesh, which is related to what we want to discuss. Mesh 3, Mesh 2, Mesh 1. Right. Okay, so those are connected, and because they are connected, we get a connectivity between our cluster, right? So I also have a bunch of clusters, obviously. My clusters are there. So I have 4 clusters, but only 3 which are connected together. So this one is my first cluster. And if we have a look at that, maybe I can reduce this one and zoom a little bit this one. Right, so you can see that network configuration is to none. Because, well, I did not specify a CNI at the installation, right? I did specify an installation with Cilium. So how did I do that? No, it's not here. I had to specify the configuration with no CNI, right? Well, what else? If I'm just okay here, I should see that I have my 4 cluster, right? I see AKS list. No, let's put that into table, and I should see that I have, yes, I have the preview extension. I have 4 clusters as I mentioned, but 3 which I'm interested in. I do have my my cluster configured for my config file. Current context, which one is it? Let's switch to the use context AKS Cilium 1. Okay, and let's do a get no, so that you can see that I have now my ready node, which means that Cilium is indeed installed, because if it was not installed, my node would not be ready, right? I can check get all in kube system. You still see that I have some object, right? I do have some Cilium object. Okay, that's it for now. Let's just go into the next section. So we are going to play a bit about with Cilium in this section. First thing first, I mentioned that I had to deploy Cilium after the provisioning of my cluster, but also there are some specificities because I want to use Cilium with the cluster mesh. I also have some requirement. I need to deactivate kubeproxy. By default, as you probably know, Kubernetes is relying on kubeproxy for its network, right? When we want to use advanced feature in network feature of Cilium, we have the option to replace kubeproxy with some Cilium configuration. But to do that, we need to tell to AKS that we don't want to have kubeproxy enabled. So that's something that can be done through the API. You can see here that I have one sample with an AZ API update resource, which we could do the same with Bicep or ARM template or even some AZ CLI. But since I provisioned my cluster with Terraform, I use this one, right? And with that, let's switch back on this one. If I look somewhere to some kubeproxy, I'm going fast, right? But trust me, there is no trace of kubeproxy here, because kubeproxy was replaced by some Cilium pod, right? Okay, next, because we want to configure our cluster mesh, we also need to prepare our Cilium so that it can work with cluster mesh, and we need to specify a bunch of parameters. First, we will need to pass to the Cilium configuration the IPAM operator cluster pool IPv4 pod CIDR list, which is a long argument name, but kind of clear. That means that we need to specify which pod CIDR that we use with our cluster, which is something that I specified in my configuration. I will show you that. Well, let's switch back to my cluster, right? I can see it over there. So my pod CIDR is not visible here, so I cannot see it here. But if I remember correctly, when I created my cluster, I had something like that available. Let me check. It's over there, here. Yep. So you can see here. I need to reduce that, just to give you a view of my cluster configuration. I specified in my cluster the pod CIDR, even if it's not visible because Azure has no idea what is being used. We just specified that inside the the deployment, right? Because it's still a required parameter, even if it's not managed by Azure the same way as usual. So I used a specific range with a big /16 range so that I was able to make it work the way I want, right? Then, because I will need to identify each cluster one way or another together, I need to specify the cluster ID and the cluster name. Each of those parameters must be unique. So the cluster ID is supposed to be a digit. So that's why we have cluster ID 1 in this case, and the other one will be 2 or 3 because I have 3 clusters in the target. I need also to specify the cluster name. So in this case, I specified cluster 1, but I could have specified the same name as the cluster in the Azure part, and I need also to specify the resource group. I have other arguments for Cilium configuration, such as enabling Hubble or stuff like that. I also need to add another parameter which allows me to specify that I won't use I'm not using kubeproxy, and so I need to replace kubeproxy into my configuration. Okay. Once that's done, well, I need to configure, verify that my cluster is working correctly, and configure and that Cilium is working correctly, and then configure the mesh. Before doing that, let's have a look at our cluster. So here we have cluster 1, if I'm correct. Config current context is okay, cluster 1. So if I'm doing Cilium status, wait, I should get the status of Cilium. It should be okay. If it's not okay, it's not so good. Well, it should be okay because I kind of cheated. I prepared my cluster beforehand, but well, you can see that everything is okay. If I'm doing that on my other cluster, I can specify AKS Cilium mesh 2. Yeah, this is Cilium mesh. Working fine. And now the third one. And everything is fine. You can see here that cluster mesh is already enabled, but how can we do that? Well, quite simply. We just need to, well, have the Cilium client installed, obviously, have connectivity between our cluster. Also, I mentioned the unique name and ID of the cluster that we can find into the deployment configuration. And also, and then I can use the Cilium cluster mesh enable, and it will propagate it will enable the cluster mesh feature to be installed. You can see here that there is an auto-exposing service within Azure VPC, because we are calling that VPC at Cilium, don't know why. It means that we have one service that is exposed. It's interesting because we should have a look at that. So let's clear that. Let's do a get SVC in kube system, right? And here you can see that we have cluster mesh API server, which is a private IP. So I have a cluster IP and also an external, a kind of service load balancer. So this is, if you remember well, my previous schema. Let's switch back over there. This is not this one, this one. So this is the infamous LB that you can see in purple on this screen that is exposed within our cluster, right? So I could probably see the same in the other context. AKS mesh 2, it will be a different IP address, right? Cluster mesh API 21.18.7, the one is 17.5, and if I'm looking at the 3, 19.7, right? If I just have a look at my Azure configuration, so this is not the good page, this is this one. I have my configuration. If I'm going to the settings, networking, everything is deployed in this network. virtual network integration. So the virtual network is here, the subnet is here. If I click on this subnet, you will find that yep. So this is my first subnet. So this is the subnet 1, sub 1, 2117, and remember the IP of the load balancer was in 7, I think. So if I'm looking at connected device, I should see load balancer. Yep, over there, and we can see that it's somewhere here. Let's check into the background configuration of the cluster over there. I just want to see the resource group, right? So the resource group is here, and in this resource group, because I have an internal load, service, I should have an internal load balancer, which is this one, and this load balancer has the IP over there. Settings, front-end IP configuration. 5, right? And if I'm correct, it was 5, right? So we can find the corresponding load balancer that is exposing the etcd proxy. Nice. Okay. So for now, let's reduce that. So once I have enabled my cluster mesh, I should be able to find that. Let's run this command. Clear, and then Cilium cluster mesh status, and it's giving me back my service. It's also showing me the number of global service, but we'll have a look at that afterward, right? For the installation, well, for the configuration, it's quite easy. Then we still need to mesh our cluster. So this is done with Cilium cluster mesh connect and specifying the destination context depending where you start. So if you are on cluster 1, you would specify the cluster 2 as a destination context. So it would, in this case, it would mesh in two sides, right? From cluster 1 to cluster 2 and from cluster 2 to cluster 1, right? The same way it's done with network peering, as a matter of fact. Then we would need to do the same for cluster 1 to cluster 3 and cluster 2 to cluster 3, and then we get a 3 mesh cluster. There are new commands available to mesh more than one or two clusters together at the same time. In this demonstration, we don't really care about that, but if we had to do it, we could mesh more than one cluster at a time. Okay. Let's have a look at the application about the across the cluster. So I mentioned that one of the use case, well, in the use case of the cluster mesh, we have application replicated across clusters. So we have high availability, or we have shared service. In this case, well, this is the kind of the same availability cluster wide. Cross cluster, sorry. We can also have an organization between the application, the service that are exposed, either private or public on on different cluster, and stuff like that, right? The interesting part here, you can see that we have a standard application. This is a demo Microsoft application that exposes something like you can see on the screen, but when we are using the service, we have annotation specific to the cluster mesh, which is the service.cilium.io/global. It can be either true or false, and then we have service.cilium.io/shared to specify that the application will be shared. So that makes an application global. That means also that I need to have the application replicated on all the cluster, so that it can be used and then accessed across cluster, whatever the place on the cluster or the expose point. Let's have a look, right? Switching back to my environment, let's clear that. I have a namespace. You can see this is mesh test, so let's get everything in mesh test. So what do we have? Let's do not all but deployment, because everything is deployment here. So you can see that I have well, more than one application because I did some tests, right? But the most important one is this one, the Hello World one, and this one which I will use to propagate my well, not to access my application. Okay. If I have a look at what my application look like, well, that's good because I have that here. This is a simple application. It's just that I change for each cluster the text so that I can differentiate between the application, the instance, sorry, that I'm accessing for this cluster. Okay, so if I'm accessing from some place, from some client point, the application, the global application, I will know which version I have by the answer that I get, right? That's just for the purpose of this demonstration. If not, we will obviously use the same application because it should be replicated. Okay, let's have a look. If I remember correctly, yep. So you may have seen that I've used more than one application. There is one which is called FF test, FF for Firefox. This is a sample Firefox so that I can use something graphical inside my application. It is much more well, user friendly. So let's just get pod minus n mesh test FF. Can I get the image? No, I don't get the image, so I need to describe. Sorry, this is not get. And if I look at that, the container image is Linux server Firefox, right? Perfect, so that's just what I wanted to show. What I want to do now is to expose or to port forward my Firefox deployment so that I can go inside my cluster and have access to my application, because those applications are not exposed on the outside yet. Okay, so now I'm exposing that. Let's switch on my presentation over there, here. So if I'm doing the HTTPS, yep, this one should be right. Obviously, this is unsecure, but I don't care. This is private. And here I can get, after some instance, my application, right? And if I'm correct, my application name should be, yes, let's authorize that. HTTP / what is it already? Mesh test. Hello World WAN. Right, if I refresh, what's happening? Well, at one point I should have another answer, but I'm not sure it will be visible that way. Oh, no, it's not working like that. Sorry. I still get one. Okay, that's not very interesting, but I plan for that. Let's use a little script so that I can repeat my my curl, as a matter of fact. So let's just show that. I have written a little script like that, and you can see that I'm doing 35 times a curl on the AKS Hello World WAN. Which context am I here already? Config. Okay, perfect. So let's run this script now. Bash paste, and this one you can see, as opposite to the graphical version, I get cluster 3, cluster 1, cluster 2, cluster 1, cluster 2. So it will do that 35 times, right? So I do have, with the same service name, network load balancing between all my different instances, right? That's nice. That means that it's working. What can I think about now? I mentioned earlier, we'll wait once it's finished. We had a look at some of the annotation that allow us to make the service global, right? So let's have a look. Get services -n. What is it already? Mesh test. Right. If I'm doing a describe this time. No, not describe. I will do a get. Let's put that in JSON. But do a GQ metadata. Yes, obviously it cannot work. Get service, and it was oh, come on. Okay, this one. Okay, so this is the one I want to get. Let's do JSON, right? Let's do this time a GQ so that I can get only the metadata, and the metadata I want to get annotation if I can. Yes, perfect. So you can see here I have two annotation: service Cilium IO global, true, and service Cilium IO shared. This one is false, but this is because I prepared this configuration. It should be true, meaning that the service is shared across all the cluster. This service is global, but it's not shared, so that means that it's accessible locally, but it should not be accessible from elsewhere. Can I verify that? Let's check. AKS Cilium Mesh 2. I should have some change if I prepare that. Everything is true over there. And I also have another one which is affinity local. So this is another annotation to encourage the service to be checked only locally. So we'll demonstrate that afterward. And then let's have a look on the 3. And this one is the default configuration. Okay, perfect. So because I've done that, so if I'm correct, that means that because the service is not shared on cluster 1, if I'm doing the script that I did earlier, but from another context, so let's say the cluster 2, I should have no answer from cluster 1, right? Use context, AKS, Cilium, 2. Okay. Let's do that. I will let it go, and I get cluster 2, and should get a lot more of cluster 2 than something else. Maybe some cluster 3 at one point. No, I should get only cluster 2 because better than that, this one is has an affinity for local, so I should get only cluster 2, and this is what I seem to get. Let's switch to cluster 3, and in this one I should get only cluster 2 and cluster 3 because this is the default configuration, but the cluster 1 is disabled, right? Two, three, 2, 3, 2, 3. Perfect. It seems to be good. Right. Okay, so let's switch back. No, not this one. This one. Okay. So I'm able to deploy application across clusters, so I need to have instance across all clusters, but then the service is global if I want it to be global, and I can also configure some affinity or some sharing configuration, right? That's perfect. That means that my cluster is working, my cluster mesh is working, and I have one of the use cases that I mentioned earlier, which is the cross-cluster application hosting. Okay, so that's nice. So now, if I'm thinking about if I look at that a little bit more, my cluster mesh is living in an environment where the network is connected, so that I can get connectivity between my cluster, right? I'm using, in this case, a virtual hub in a virtual WAN, and I mentioned quite rapidly earlier, but I did that I did not deploy an Azure firewall into my virtual hub. I could. In this case, if I'm deploying a firewall, that means that, let's assume that I configure everything so that the flows are going through this firewall, and so I have a view of these flows and I can secure the different flows. Then I would have by default the connectivity between my cluster. There are two important points here. The first one is that if I want to deploy a firewall and make it work, the first thing that I need to identify is which are the required service ports, so that the cluster mesh is working. So that's something that is documented into the documentation of Cilium. And if I remember correctly, yep, this is something like that. I need to allow, you can see it here, I need to allow, depending on the encapsulation mode, either the UDP 8472, or if I'm using GNAV 6081, right? But I did not deploy an Azure firewall, as you may have seen. And why did I not do that? Because, you probably are thinking, let's be secure, right? Well, this is something to discussion, but the idea with the cluster, with Kubernetes, is that we have a network overlay and then an abstraction from the underlying infrastructure, including the network part. So I can always use an Azure firewall and then manage the flows between my virtual network. But should I do that? Because I mentioned also in the introduction that because Cilium allows me to do cluster-wide network policy, I can also configure my cluster to, by default, refuse everything that is not coming. I can deny everything, as a matter of fact, but I could also have, by default, a service that is not allowing a network policy that is blocking everything that is coming not from this cluster. And then in this case, do I need to move out of the Kubernetes control plane to use an Azure firewall? Well, I'm not so sure. It will depend on the team maturity, but if the visibility and the observability is configured as it should be correctly, from my point of view, I think it becomes redundant. So obviously it will also depend if you have more than one kind of application, application hosting solution. So if everything is not on Kubernetes, maybe you need to still manage some network filtering at a place where you can do it. So it would make sense. Or we could also have a dedicated hub, because you probably know that we can have more than one virtual hub in your virtual WAN, and one dedicated hub for the clusters, the AKS cluster that are meshed, and it will work. Just to tell, I'm not sure really that we should still use an Azure firewall, right? Now about the internet exposure, right? Well, this is one solution here. I have a cluster mesh, meaning that I can have, because I have your virtual hub, I can have also virtual network into different regions. So I could have multi-region application, which was not something easy to do with one cluster in one region. So in this case, we have more than one cluster, but one unique control plane across different virtual networks, so potentially across different region, right? So how do I expose application? So there are different solutions. You can aim to the solution with the external exposure, meaning external solution to expose. So in this case, I've written a front door, but it could be also a virtual network hosting in different region, or in only one region, I don't know, an application gateway. The idea here is that we will split the exposition and the WAF configuration from Kubernetes. It could work. It seems doable. There are still some thought about that. Do I expose? How do I expose my application with front door, which is global? It can make sense to have more than one endpoint for the application in different clusters. But then, do I leverage the cluster mesh capability? Well, not for the exposed service directly, more for backend service that are not necessarily the one that are exposed on the front door, right? I could also dedicate, because I mentioned also that the use case could be identifying the service by kind. So I have public service and not public service. So I have one or two clusters which are public, meaning that those clusters are public. So in this case, I could have one of the cluster dedicated to expose public service, and then the other service would be, the private service would be accessed from the public service if needed. But in this case, we are starting to go into the service mesh configuration with all of the gateway configuration. So that's another topic. Okay, but what we should remember, now that we have finished our discussion, we can do cluster mesh with Cilium. Hopefully it will come in a more managed way with the Azure CNI powered by Cilium, but there are more and more things coming into that, so that's nice. We can leverage the Cilium cluster mesh capabilities. There are also other Cilium capabilities that can be added into a cluster with the cluster mesh. So the first one being that we are not using kuproxy anymore, but something that is much more advanced, which is Cilium. Nice. There are also the encryption, if I remember correctly, that we can leverage inside Cilium between the different clusters of the mesh. So we can have an encryption on the network. So that's interesting. And again, it asks the question: do we need to have additional layer filtering under the hood if we can filter in Kubernetes and encrypt in Kubernetes? I'm not sure, right? What can I say again? So we talk about the additional feature with Cilium. So well, that means that Cilium is quite an interesting solution to have a global application and then a global control plane, because in this case, because we have the etcd proxy, we do have a global control plane, even if it's under the hood separated by read-only service. We do get that. So associated with the proper tooling for the operation, the monitoring and stuff like that, we can have a Kubernetes platform that is multi-cluster and that help us to reach the aim of everything in Kubernetes, if that's what we want to do, right? If not, well, we don't use Kubernetes, so we don't really care. But just remember, Cilium also is supposed to regroup the feature of the, well, exposition, so we didn't talk about that, but the network, advanced network feature, some observability, and also some service mesh feature, which have evolved a lot, as you may know, with the Gamma project and the Gateway API project. So Cilium is ready to do that. So in a multi-cluster environment, it can make sense, but well, I'm limited on time, and also we don't want to do too much technical stuff. So to further this reflection, we'll probably need to have a look at the other Cilium feature for global service and micro-segmentation and stuff like that. But suffice to say that at this point, we have a very interesting feature to have resiliency and distribution of service into Kubernetes, right? And that's all for me for today. So I thank you for your attention. You can click on the Festive Tech calendar link below. You will find the charity organization that we are sponsoring this year. Thanks for watching this video, and I hope to be back next year. Thanks. Bye.